As another application of the conditional formula, we're now going to derive something called Bayes' formula, or sometimes Bayes' theorem. It's a very powerful idea. It gives the relationship between the probability of A given B and the probability of B given A. Now, of course, if they're independent, that's easy. The probability of A given B is just the probability of A, and the probability of B given A is just the probability of B. But what if they're not? Well, the answer in general is given by Bayes' formula, and we'll see the Bayes' formula is very powerful. So let's write out Bayes' formula first. So it's the probability of A given B is just equal to the probability of B given A flipped around times a factor, which is the probability of A over the probability of B. Now, sometimes one of these two is easy to calculate and the other one is difficult, but we'll see that that this formula is rather straightforward to derive. So we just write the probability of A and B in two different ways, which I've done here, conditioning in different orders, and then divide through by the probability of B. If you divide through by the probability of B, you see that we just end up with Bayes' formula. All right, so it gives that the probability of A given B is equal to the probability of B given A times this factor, the probability of A over the probability of B. And the main power in this is sometimes one of these conditional probabilities is very obvious how to calculate, and the other one is not intuitive at all. All right, did you see that? Let's do an example now. All right, to help us understand the power-Bayes theorem, let's return to the example that we used when just calculating tree diagrams using the rule of total probability. Let's use this example. We have two boxes. One box labeled heads box and one labeled the tail box. The head box has 2 black balls and 2 white balls, and the tail box has 1 black ball and 3 white balls. And now we want to ask a different question. So we're going to again let A be the probability of picking a black ball. We saw that that was 3/8 earlier, but what if we say, okay, I know that I picked a black ball. What's the probability that the box I used was the H box? Now, it's easy to calculate the probability of picking a black ball if we know we picked from the H box. That's just 1/2. We saw that before. So one direction is easy, but the other direction is hard. And now we're going to use Bayes' formula to calculate, which might not be immediately intuitive, what's the probability of having used the H box given that I see that I picked a black ball. So what I've written out now is just Bayes' formula. And let's block this off so we don't get confused what's equal to what. And now let's just fill in these numbers. We know all of them. The first one is 1/2. The probability of picking a black ball we already calculated in the previous video was 3/8. And the probability of picking a black ball given the H box is 1/2. So we just simplify all this algebra, and 1/2 times 1/2 is 1/4 times 8/3, which is just 2/3. So the probability of having used the H box given that I know that I picked a black ball is 2/3. And we'll see that this is a really powerful technique for calculating probabilities which are not immediately accessible to us, and we don't have a nice intuitive understanding of what the calculation should give. Now, we could also ask about the other direction. What's the probability of having picked using the tail box given that I saw that I have a black ball? All right, now let's calculate the probability of having picked from the tail box given that I see a black. It's exactly the same calculation, but it's just good practice to do it both ways. So we'll just calculate, slide the paper up a little. So the probability of using the tail box given that I see a black ball is just, again, using Bayes' formula. We have an exactly analogous formula, so let's write that down. And now let's fill in what the answer is. So we know the probability of picking the tail box is 1/2. The probability of picking a black ball using the tail box is 1/4. And then the probability of picking a black ball is again 3/8, and we get 1/3. Now notice that 1/3 plus 2/3 sum to 1. Well, that makes sense because there's only two options. Regardless of the fact that I know that I picked a black ball, I either use the tail box or I use the head box. So the sum of those two probabilities, they're disjoint, and they must sum to 1 because they're the only two only two possibilities. So we just calculate those two, and we see that yes, 1/2 plus 1/3. 2/3 plus 1/3. Let's try that one more time. 2/3 plus 1/3 is 1, because the sum of the probabilities must be equal to 1, because they're the only two options and they're disjoint.